Good day, grade 9s. How are you guys doing? Welcome to this physical science lesson, 13th lesson. I hope you guys are well and that you enjoyed your weekend. Today we're going to be looking at the topic work. We're going to be looking at the topic work, and we have just some simple objectives that we want to meet before we reach the end of this lesson. By the end of this lesson, we should be able to define the term work, give examples of situations in which work is done, and carry out calculations to show work done. So the main thing that we want to do is to be able to actually say that work is done in such situations, because there is a confusion in the work that we think we do in our daily lives as opposed to the work that we actually do in the physics sense, right? In the sense of physics, say what exactly is work done, right? So just look at the objectives and get ready for the lesson. Okay, so we'll find that in our daily lives, there is this conception, this thinking that anything that makes us tired is known as work. Reading, writing, painting. You see, there's some examples here of what we would call work just in our daily lives, right? But in physics, we'll find that work is the force applied over a distance in a particular direction, okay? In a particular direction, it says in the same direction. So if there is a force that is being applied and it's being applied in a certain direction, and there is a movement of the object, right, which the force is being applied on. So if you apply a certain force to a certain object and there is a force that is applied and a consequential resultant movement, then we will say work has been done. We will say work has been done, which is why we say here, I put for you in your notes, say work has a specific meaning which differs from the common meaning in everyday language. So I gave you the definition that we want to use here in physics. So you can read on this definition and you will find that work is done when a force is applied on a body and moves it for a certain distance. Work is done when a force is applied on a body and moves it for a certain distance. You will find that this is critical when you talk about work. If there is no distance moved in physics, then no work has been done. Then no work has been done. Okay? So we will see that here is another way of defining it. It's basically the same way. It's basically the same way. But I just put these images there so that you can have an understanding, just to see different images, to see different ways in which it is done, right? But work is said to be done when a force F acts on the body and the point of application of the force is displaced, right? So displacement is the same as movement. So when you say force times displacement, that's force times distance, right? Force displacement is the same as distance moved, right? When we get to, or if you ask your grade 10 brothers and sisters, I explain to them the difference between distance and displacement, okay? But basically, that is the unit or the way for calculating force. So here we will also find, here is a lady, for some reason she is pushing the wall. Let's go here, this one. She is pushing the wall. Force is applied on the wall, but no displacement takes place. So in that case, would you say work is done? No, work is not done. So if F force, let's also remember the symbols, yes? The unit for force is the Newton, but when we abbreviate force, we write F. So if F is equals to 0, then work done is also 0. If displacement is 0, distance moved by the object on which you are applying force is 0, then work done is also equal to 0, right? So the conditions required for work to be done are these ones. A force should act on an object, and the object must be displaced. Here you have an image of, this is a cricketer. I hope you guys know cricket. You know, guys, you know I like cricket. I love cricket, right? Sport I used to play. So if a cricketer hits the ball is going to be thrown at the batsman. The batsman hits the ball and applies a force by swinging the bat. He hits the ball with a certain amount of force, and that ball is going to move a very long distance. So what you're going to do is you're going to calculate the force which the batsman applied and the distance which the ball moved, and you can then calculate the work done, right? The work done on the ball or by the ball as it moves, right? So there's going to be a force applied, and there's going to be a particular distance that is moved. So we can also see here that it's the same thing that I highlighted here, say point to naught. Unless the force applied makes the body move, there will be no work done. So it says here, work is also defined or explained as being a transfer of energy from one form to another, and that no work is done by a person who is standing and holding a pile of books or a pile of bricks. I think we've given that example. We gave that example even when we were in grade 8 to say, if I say to you, can you please carry this pile of books for me? And then I let you stand at the door, and I keep explaining something to the other learners, you see, and you're just standing at the door holding a pile of books. After some time, you're going to say, I'm tired now, right? You say, why are you tired? You say, I'm doing work, I'm carrying these books. But effectively, you're not actually doing work in the actual sense of work, because you're carrying a pile of books, which is a mass which can convert into a force, but because you are standing in the same position, then no work is actually being done. No work is actually being done. Right, so it's also important that we know the unit for work. Right, say what is the unit for work? And we are obviously going to get the unit of work from the quantities that are involved in calculating work. So if we are going to have work being produced as a result of force multiplied by distance, and we know that the unit for force is the Newton, and the SI unit for displacement is the meter. That means that we're going to say newtons multiplied by meters. Work is force times distance, or force times displacement, right? So it becomes newtons multiplied by meters to give you Newton meters. So that Newton meter is also equivalent to the joule. So when we say a Newton meter, that's just the same thing as 1 joule. 1 Newton meter is equal to 1 joule. 1 Newton meter is equal to 1 joule. It's equivalent, right? So that is the unit of work. So here we now have a table where I put examples of where work is done and situations where work is not done, right? So you can just compare an object falls. Because when an object falls, it falls from a certain height and it moves a certain distance. And because it has a certain mass, that means that mass is going to be changed to a weight, and weight is a force. I hope you understand that. The formula for calculating work, I already gave you that, force multiplied by distance. Please observe in these diagrams that the direction or the angle at this stage, don't worry about the 30-degree angle. Just have the individual pulling, like here, the boy is pulling with a force of 50 newtons and a distance of 30 meters is moved. So you can actually calculate the amount of work that was done in this case, right? to say if a force of 50 newtons was moved. I'm trying to tap this thing so it doesn't have something blocking it. If the force of 50 newtons was applied and a distance of 30 meters was moved, it means you can calculate the work that was done. Yes, you can calculate the work that was done. Here are some examples, not examples, but questions, which you guys will do in calculating work done. We can maybe just do them together in the lesson, right? So you just do them by yourself right now as you're watching the video, and then I will ask, those who are there to answer the questions, because that's the only thing we can do. We can ask people who are there. Those who are not there or who are hiding behind their pillows, do stay there. It's not an issue, right? So that is the topic work. That is the concept work. Very, very simple concept, as is the rest of physics and chemistry. This is what physical science. So thank you guys for watching the video. I hope we managed to cover all our objectives. Okay, so let's carry out what calculations. Just say change the mass to newtons, multiplied by distance, 65, multiplied by 3. What is 65 multiplied by 3? 60 times 3, 180. 5 times 3, 15. That gives you 195 Newton meters, or 195 joules. That will be your answer for question number 1. Yes, but you do it, you follow the steps, and you'll find that yes, it's extremely simple. So thank you very much for watching the video.